live, Jim. Let's go.
Excellent. Thank you very much, Alex. I should probably have checked as well. Alexis, are you with us?
Yes.
Fantastic. Okay, everybody. Welcome to Office Hours number 24. Just after ECC, so a lot of people just coming back from their travels to Paris. And we are still on the path towards the upgrade for Ethereum London hard fork. So we'll go straight into the NodeWatch piece and have a quick discussion about that. Then we have Alexis from Semiotic with us today to have a more in-depth discussion about the indexer stress test tool that Semiotic has developed. And maybe so we can also learn a little bit about Alexis and Semiotic in general. So let's just kick off and get right into the NodeWatch piece. Still on track for around the 4th of August for the London hard fork. I have personally heard some noise around individuals who are not happy about there not being enough time between the last incident. There was an incident on Ropsten, which I'll briefly talk about in a minute. And there not being enough time between that issue being fixed and the August the 4th date. I believe there's a ETH dev call coming up that will probably decide whether there is any kind of delay or not. But at the moment, we're all targeted August the 4th. So this Ropsten incident, during testing of the London hard fork, there was a consensus failure on Ropsten, which caused a network split between clients. So the Open Ethereum and Besu clients and the Geth and Netherman clients, there was a split between the two groups. And this was in some way related to the mechanism changes around 1559, which basically suggests that these certain transactions should be rejected, and that's where the consensus failure came from. The affected clients have been updated, to my knowledge, certainly Geth. Geth is now on 1.10.5, so they've done an upgrade, and you must upgrade to that release before the hard fork activates if you want to remain in consensus, otherwise you'll split off the main chain. Open Ethereum, no changes in Open Ethereum that I found. I just checked it this morning. Aragon have had another weekly release out, so that's July the 4th alpha release. Again, they're also sending a clear message to make sure you upgrade from the previous version before the London hard fork for exactly the same reasons, the consensus issues on Ropsten. Last note on the client stuff, we are starting an Aragon indexing working group that will be every other Thursday starting next week at 10 a.m. Pacific. So it's basically at the same time as office hours, but rather than a Tuesday, it'll be on a Thursday. The objective of this group is to get as many indexers as possible, and anyone who's interested in running an Aragon node up and running with an Aragon archive node at the latest version, so that people are clear on how to pull the latest version, how to upgrade it in situ, and how to run it properly, basically. We'll also be looking at sharing or writing POI testing scripts. So the reason here is that this change of or potential change in the dynamic around the clients that we use in the network means that there may be some differences in the POIs returned, depending on whether an indexer is using Open Ethereum or Aragon. So we want to be sure that we're monitoring all of the POIs that are out there and comparing each other to each other, and making sure that if there are significant discrepancies between our POIs, then we try and find out why there's discrepancies. And if they are repetitive issues, then we as a group take them to the Aragon team in order to have them resolved. The Aragon team now have a grant as part of Wave 2. So they're also aligned to help us fix these problems as they come up. So this is the purpose here of this call, is to try and make it so there's not 10 different indexers all going to Aragon and confusing the matter. If we find errors, we work together to bring them to their team to get them resolved. Quick note: this is very similar to the maths working group, which is on Wednesday evenings. It's more like a clinic. It's not an official call, as in it's not like there's specific pieces of information being communicated via those calls. It's purely a clinic for people to drop in, help out with the testing, get their Aragon node set up, and eventually, my hope is that the regular contributors on that call can come to a consensus about their confidence in using Aragon on mainnet, and then we will, at some point, we might all together decide that we're going to start running an Aragon nodes in mainnet. Okay, any questions on the client side of things before we move on, or anything extra people want to discuss? Right, so let's move on to our indexer tooling highlights section. So a few weeks ago now on office hours, Payne showed us, or did a demo of a tool that he was playing with against his testnet indexers. This is a indexer stress testing tool that was developed by Semiotic. Semiotic have a grant as part of wave 1 of the grants, and have been collaborating with Edge and Node, the engineers at Edge and Node, to develop this tool. The tool is capable of generating random queries, and it uses an existing piece of software from IBM called the GraphQL Query Generator. And you can, it's like any other load testing tool. You can run it in parallel to a ramp up load if you want to. So we've had a sort of demo from Payne, but we haven't heard it from Semiotic themselves. So I wanted to get Alexis on today. Welcome, Alexis.
Hi, everyone. Yeah, so we developed that IST tool, that one in particular, initially for our own indexing operations. The main thing we've learned from it really was that the graph node is very memory happy. So that was the main piece of the main help we got from this tool, but it wasn't really part of our main agreement with the Graph Foundation. However, now we're actually working on some pretty cool machine learning tools that might lead to a newer, meaner IST. So that's for the bird's eye view.
I think in some of the questions here, we'll get into more like indexer greedy questions, as in what sort of stuff you might be working on that will help indexers. But before we jump into that, Alexis, I want to get a chance to understand what was your personal story of getting into crypto. I like to ask guests this question. So what brought you into the crypto space?
Well, actually, what brought us into crypto space was really the graph, interestingly. So we got in touch with Jackson from Edge and Node through a personal connection, and he told us he saw that we were pretty good at machine learning and DevOps type of things, and first he wanted to help us. So we already had formed Semiotic AI, right? And he wanted to help us out with making a deal to help index for him, right? And that's how we got into setting up the whole indexer infrastructure, learning about the graph. So initially, I have to admit, I was highly skeptical. I didn't quite get it at first. But of course, the more I dug in, the more I learned about Ethereum, what's going on with Web3 and the dApps and DeFi and all those things. That really changed us completely. It made us really pivot into crypto. Now I'm fascinated by the stuff. I'm an Ethereum maximalist now, so that's pretty fun. That's really how we started, and also then Jackson really pushed us to apply for grants to really help with our deep learning, reinforcement learning, and cryptography expertise, and yeah, that's how we got into those grants, into working with the Graph Foundation.
Interesting. So, what was Semiotic doing prior? I mean, what are the areas of specialization that Semiotic works in?
So prior to that crypto pivot, we were really looking into fully homomorphic encryption. So it's an encryption technique that enables you to execute mathematical operations on ciphertext without decrypting. So it's addition and multiplications, but from there you can really do any polynomial, and so with polynomials then you can approximate pretty much any function. So we had grand ideas of, for example, crossing our deep learning knowledge with that full homomorphic encryption. It would have been executing neural network computation on ciphertext. And we're really aiming at B2B, helping, for example, banks run neural network operation on confidential client data, things like these. And even though it sounds really cool, and everyone we talked to said that it was really cool, turns out that the need wasn't really there yet, I guess. So we'll see in the future, but we didn't really pursue this. However, now that we're delving into the cryptocurrency space, we're certainly thinking about where that could be applied, right? So for now, we're not really sure, but if you guys have ideas, I'm really interested.
This is maybe a bit of a layman's question when it comes to the maths and the homomorphic encryption piece. Is there any synergy between homomorphic encryption and the types of work that are being done in the zero knowledge space?
Yes, there is. What's interesting is that in the work we were doing before Pivot, we were looking also at accelerating the computations that are related to FHE. And those computations are hard, mainly because you have to multiply very large polynomials together. And it turns out that in certain zero knowledge algorithms, you need to do exactly that. So that's really an area where we already have expertise, and we really see ourselves being able to accelerate ZK proofs significantly.
That's very interesting. That's a really exciting area of crypto at the moment. So let's pivot a bit into more about your indexer operation, right? So I'm aware that Semiotic is running an indexer operation at the moment on mainnet called joystick.eth. So I'd be interested to know, from your perspective, Alexis, what's the indexer experience been like for you in the areas that are sort of out of the Semiotic wheelhouse? How's the experience of operating indexer been for you guys, both on the testnet side and the mainnet side?
Well, the start was really painful. So my choice was to run everything on Google's Kubernetes, and I based our Kubernetes setup on the one that's on the indexer repo of the Graph GitHub, right? And it was pretty hard. I had a hard time understanding all the pieces, understanding how to make them talk to each other correctly. So that was very tricky. But yeah, overall, after a few weeks, I ended up having something that works. I was really happy to be able to start on the testnet. So that was great. Initially, the testnet, I believe when I started out, the testnet wasn't open. So it was really maybe just a few weeks after we started out. So that was back in February, I think, February, March. So yeah, the open testnet was really a huge help. That was really great. But back then, the main pain for us was Ethereum nodes. It still is. So I tried to sync an open Ethereum node on a VPS with SSDs, with NVMe SSDs, and I never quite got to finish. So right now, sadly, we have to we use an external service, and we can't use trace enabled subgraphs. But yeah, overall, it's not that bad. Really, now our main my main worry is how to choose subgraphs, knowing that it seems that most subgraphs right now seem to be landmines. I don't know what's your input on this.
Yeah, I get exactly where you're coming from. It's choosing your subgraphs right now is risky, right? And it's more, I've written a guide about how to do this and signal weighting, stake weighting, etc. But the reality of the network right now is that it's more of a human interaction than it is of something that you can turn into like a basic sorting algorithm or something like that, right? You have to sort of assess every single choice you make with your own brain.
We're curating the curation.
Yeah, chicken and egg, right? We talked about this last week. The indexers just naturally happen to be in a position where they're closer to the subgraph devs maybe at the moment, in a way, where they're a bit more in touch with what's going on, just because of where we sit in the ecosystem. So often it seems like the stake is leading rather than the signal leading, or the signal's leading in the potentially not the right direction. I think, and all of these things are symptoms of the birth part of the network, the growth part of the network.
Yeah, I guess that when we'll get more public information about which subgraphs got queries, it will be probably a little bit more relaxed.
Yeah, I think so. I think it will help a lot. I mean, that's the main function of Signal, right? Is to signal how much query business we expect there to be on a subgraph. For the moment, the volatility, in my eyes, is mostly down to the total volume of signal, right? So the liquidity, the signal liquidity, compared to the rest of the network. It's magnitude smaller at this point. So I think the growth of the signal liquidity, or the total volume of signal, it will help negate a lot of the pain points that we're feeling as indexers every time there's some significant event happening on just the one subgraph.
Yeah.
So moving on again, well, let's just quickly go back to the indexer stress testing tool. I know Alex did give us a brief demo last or a couple of weeks ago or more now. Can you just briefly explain how IST works? So from a practical point of view, what would an indexer do in order to use the load testing tool?
Yeah, so it's not a super fancy tool. It's more like a helper script. It's written in JavaScript. I mean, TypeScript. I'm not a pro in JavaScript or TypeScript, so the code might be horrible to some people. I'm sorry for that. But in any case, what it's doing really is that it will use, first of all, the schema of the targeted subgraph. So it will download. One of the steps that you can see on the kit.readme is that you have to save the endpoint schema, and then you save the endpoint provider map. That's a terminology that's used in the IBM GraphQL query generator. And what it really does here in particular is just gather all the possible IDs that exist for each type you can ask for in the subgraph. And that's really just to fill it in randomly afterwards when you do the query generation. And then the stress test will just do that. So it will it will query for random types and random data, and it will do random nesting also, and it might also ask for random IDs for the right types. That's pretty much all it does. So it's not super fancy. It will not vary, for example, at least as of now, how many skip you do, how many first element you ask for, and even less the where argument. That's a tricky one to fill in, and it doesn't play with that either. So it's not a it's good at generating traffic, but it's not a very broad testing tool.
Got it. So something I picked up on the forum was Alex had a question, I think, around where you can actually point the tool at. And I understand you can point it both at the graph node and the service nodes as well. Is that right?
Yeah, you can point it anywhere. So as long as it's a valid GraphQL endpoint, you can do it pretty much.
Got it. So what in using the tool yourself, have you found anything interesting already yourself in terms of the impact that putting such heavy load might have on your testnet infrastructure or mainnet infrastructure? I'm assuming you could point it at either if you really wanted to, right?
Yeah. Mainly memory. Memory was my main problem. The graph node, when you use that tool, the graph node will use a huge amount of memory. And when I used it on my testnet, it was repeatedly crashing my graph node.
Wow.
So yeah, Sorry?
I said, wow. So I was actually expecting to come back immediately with something around the database.
No, not the database. Database was fine, I/O was fine, CPU usage was okay. It's just the memory. And sadly, memory is the most expensive thing. It's the most expensive piece of hardware. From a standpoint, at least, right? That's the most expensive thing. So that wasn't great. So can't do much about it. So on my mainnet now, I've deactivated cache. All possible caches, but it still uses a lot of memory. So sometimes it crashes. That's it. I just put a memory limit, and if it crashes, it crashes, and it restarts automatically. That's it.
Interesting. So, what immediately comes to mind for me is, can we scale our query nodes? Has anyone actually? I know we scale our service nodes, but can we also horizontally scale our query nodes? I'm assuming we can.
Yeah. Yes, you can do that. So maybe one trick would be to have at least 2 query nodes. And so the advantage there is that Kubernetes will kill the one that uses too much memory, and you have a backup while it's not crashed yet. You can restart and then kill the other one when that one starts also using too much memory.
Yeah.
So, yeah.
Very interesting. Something to definitely keep in mind, that we want to be on top of that type of dynamic prior to real query business really ramping up.
Yeah, I've noticed the issue already actually on the mainnet, and so now that I've deactivated all caches, I'm stabilized at around 1-2 gigabytes of RAM for the graph node. But that's with explicitly asking the graph node to not use any cache at all. If I do activate the cache, then it just breaks through very quickly.
I see. So I'm assuming that when you talk about cache, you're talking about the caching of queries, right?
Yeah, there's two options. I don't have them right now, but there's 2 options. You can say which subgraphs you want to cache. So you give it an empty list, and there is another cache option and a cache size, and I gave it 0, and it helps, but it's not perfect.
Very interesting. So I imagine that you could also port that list if you were to have a list of premium subgraphs that would get the ability to use memory, and then you would somehow pipe that into your cost models for those specific subgraphs that they're using more of your infrastructure in order to have a performant query business.
Yeah, I haven't played with this, but probably, yeah.
Cool. So another question I actually just put in here while we were talking. I just wanted to get your sort of opinion on this. So if we imagine that we have some of the advanced tools that, in your forum post, you talked about some of the things that Semiotic is working on in the graph space, much more advanced than the tool that you've already delivered.
Yeah.
Do you have any thoughts about what the indexer and the subgraph allocation landscape might look like in 2 to 3 years if we can implement the sorts of advanced technology that you guys are working on, the advanced insights you can get from the data that you're collecting?
Well, what I envision is an easier to use Agora. So that would be a great start. I have to admit myself, I can't take the time to play with Agora, so I've just standard pricing. I don't know about you guys, but yeah, the idea would be that the neural net would help you determine the actual hardware cost of a query. And that would be through training, so through real world data, right? And you can envision many things, and so there's different steps in terms of the fanciness of that model. The first one that you can start with, for example, and we're training right now, is one that classifies queries as taking less or more than 1 second. I don't know if that's the limit that will be really used, but you can use something like this for DOS protection, right? We could retrain for 10 seconds or something like that. But you could push further. You can do actually regression, which means that instead of just classifying, you could say, oh, my neural net predicts the actual time it will take, right? And so it could tell you exactly how many milliseconds it would take to run a query, assuming that your server is not doing anything else at the moment, right? So it would be like the intrinsic time it takes for a query to be run. Then you could push further. You could actually monitor how many CPU cycles are used by the graph node and Postgres, as well as how much memory and how much I/O and how much network egress, and try to predict those things too. So then you could also decide to have a pricing model that depends on that's a function of the predicted infrastructure costs. So there are many things that we're planning to do in the future, and we will not stop there, of course, but this is pretty much the idea. And so then the question is also how is it okay to have a generic pre-trained network that will predict CPU cycles and etc. for each query, or should we also enable a way for indexers, if they wish to do so, to fine-tune the neural network for their own hardware or their own setups, instead of just applying coefficients on the predicted generic infrastructure costs. So yeah, these are the ideas, at least intermediate ideas, and but it really depends on the indexer's view of such a system, right? Because we, of course, want to keep the freedom. We want indexers to still have the freedom to price things the way they want, and not feel that we're imposing a neural net that's really a magic black box that prices things for them, right? So that's also the question. How do we make sure that indexers have the freedom? So that's pretty much that. So I'd like to hear your ideas.
Yeah, so you've basically picked, I think, probably the most complex problem for indexers, and the one that most of us, I'm not afraid to admit it, I'm ignoring it right now. And I know how important it is, so it's in the back of my mind that pricing is a really hard task, right? I mean, where am I at with my pricing right now? I'm working on the collection of the data, right? That's what I'm most concerned with right now, collecting the data via Qlog. and then putting it somewhere so it can be used later. So the question of actually dealing with the pricing, or pricing accurately, pricing fairly, both for the consumer and the market against your other indexers, is a really difficult one that none of us can really answer, to my knowledge. Nobody's certainly talking that much about it right now. And I think it's very clear to a lot of us in the discussions I have with other indexers that, data service businesses, like many, SaaS businesses, run on they end up running on a very, very razor thin margin. And once you're at that point where the competition is a razor thin margin, it's solutions like this that set, maybe a passive indexer apart from a really active indexer who's looking at their data and tuning and looking at the business demand and that sort of stuff. So I think all of this stuff is really, really important for the future. And we will struggle as indexers when the gravy trains are not so full of gravy anymore. We will struggle if we're not on top of this sort of thing, and we're not on top of our demand. We're not on top of the balance between indexer rewards and query fees, because at some point, if this is going to go the way we expect it to go, then there's going to come a time when the query fee side of the market is the one that we're all spending our time trying to pull in profit from, right? So I think this stuff is really, really important. I would be interested though to hear Chris from GraphOps' opinion, on this approach. Do you see other approaches, Chris, as well for the query fee side of the market?
Yeah, thanks for the call out, Jim. Somewhat sarcastically. I guess I had one question for Alexis, and that is, have you thought about training the neural network against the outcomes generated by the Postgres query planner?
So what do you mean by the outcome?
So obviously with the query planner, you can feed an arbitrary query in, and it will generate a plan that it would follow to retrieve the data to answer the query. And the query planner, is capable of generating a very, strong approximation of the cost associated with any specific query. So, the approach of kind of like treating the database as a black box and, setting up probes like, measuring memory pressure or I/O or whatever is one way. But, the Postgres query planner kind of gives us this interface to, leverage the query engine to actually approximate cost for a given query. So it feels like that might be a really good agent to train the model with.
Yeah, that's an interesting idea indeed. However, so does every GraphQL query translate into one query plan in the Postgres?
Every GraphQL query will translate into a single, a deterministic set of SQL statements. That determinism will be based on other factors like what indices are present in the database. But yeah, you can roughly map GraphQL query to SQL query to query plan. And yeah, as you change indices or other options, that plan may vary, but generally it's fairly deterministic.
However, yeah.
Sorry to interject. Yeah, one thing I'd add here is just that the SQL query planner actually isn't quite as effective as you think it might be. There's a few papers that we were looking at about a year ago, and I'll share them with Jim so he can distribute them in the right places. But the planner actually for any given query is quite bad. If you look at like the standard error of like its predicted query time versus like what it actually ends up being, and part of that is because it does a very poor job of estimating what's called predicate selectivity. So the idea that like you have these query like filter predicates and a priori the query planner has a difficult time learning or knowing, what a given, like how much a given filter predicate is going to reduce the set of like entities in a given table. And right, you might have multiple of these filters on different columns in the table, and that has a pretty big impact on the performance of the query, because if you apply like the predicate selectivity, if you apply like the filter, for example, on one column, thinking that it has a very high predicate selectivity, or that it's going to filter the results down to like a very small set, but actually it ends up being a much larger set, then you might end up actually doing like a linear operation over a much larger set of entities than you initially thought at the outset. And so that's one of the things that the Postgres query planner tends to struggle with, is like making those types of estimations. And I don't believe it does any types of like online learning or anything where it could even improve its estimations in an online fashion over time. I believe the algorithms are mostly based on heuristics that are sort of static. And so we'd expect that over time, I think the types of work that Semiotics is doing, with neural networks and with online learning, could probably outperform some of the estimations of the SQL query planner, or specifically the Postgres query planner. But it is really interesting to start looking at things down at the level of the query plan, right? So like maybe, where some of this could go in the future is like you could even have an online learning algorithm that starts forcing certain query plans that have been or start selecting certain query plans that have been generated by the query planner, as opposed to letting the planner itself, select the best plan. So yeah, I'm happy to share those papers, but that was a kind of a big thing we were looking at about a year ago.
And also, another way to see that problem with training on the GraphQL query versus the actual plan is that if the GraphQL query is translated into a plan, then training on one or the other ends up being the same thing. It's just you're told the same information in two different languages. Because the way we're training is really, you put GraphQL query on one side and you put, let's say, latency on the other, and that's it. And you treat everything as a black box. And putting the plan on one side and the timing on the other side should end up leading to a similar statistics. I don't know if that was your what you hinted at, though, Chris. Replacing the plan instead of the GraphQL.
Yeah, my suggestion wasn't so much to use the plan itself as some kind of input, but rather, yeah, Brandon seems that was super interesting, Brandon. Thanks. Today I learned. But I seem to remember that the query planner is capable of giving some quantitative measure of cost. Like you can actually get a number out. So my suggestion was more along the lines of GraphQL query in to planner cost out. But yeah,
that would replace machine learning altogether if it was accurate.
Right. The cost output for so the query planner basically generates a number of plans, and then it uses heuristics to give a score, basically a quantitative score to each plan. But it's not; those scores aren't a ground truth. It's just an estimate based on the heuristics that the Postgres query planner uses. And historically, they've not been very accurate for any single query, although on average, obviously they perform well enough because we're still using Postgres, and and it's a very successful database that gets the job done in most cases.
Okay, excellent discussion, guys. Alexis, let me ask you this. In the work that you've done so far and the work that Semiotic has planned for the future, is there anything specific that you need from the indexer community?
Well, something that also Brandon needs, I guess, is what would you like to see in terms of pricing models, in terms of how would you like us to help with pricing your models. How much freedom would you like to have in terms of fine-tuning, adjusting your pricing models? Are you okay with having a neural net running on the gateway that helps price the queries for you? Would it be good enough for you to have access to that neural net, access to the whole pipeline for training, for you to double check that it's really, there is no shenanigans going on? So really things like these, right?
Yeah, that's a really interesting point. That'd be interesting to get indexer feedback on. So like in some of our recent conversations, we've talked about the topic of explainability, which is, a topic from kind of AI and machine learning, which is that, when you train one of these neural nets, it's not that you can for free understand exactly why it's costing or pricing things the way that it does. And so as we look at, what the next versions of like the negotiation protocol and like Agoric look like, for example, one option would be to, the kind of naive solution would be to actually just send one of these models, over the wire as like the sort of substrate for communication between the indexer and the consumer. But that model, while accurate, wouldn't necessarily be understandable to human eyes, right? It's not that any indexer or consumer could look at it and understand why one query is priced differently than the other. So that, A, could create uncertainty for consumers, but it also creates uncertainty for indexers, right? If you're actually trying to use this model as a way of maybe improving your setup, right? I mean, maybe, changing what things you choose to index, like what columns you choose to add indexes, what types of indexes, what things you choose to cache. And so something we've discussed is, can we use some of the work that Semiotics is doing to actually generate a model that's in a more simplified DSL that kind of gives us the property of explainability. You might lose some resolution, so that type of model might be not quite as complete as the whole like neural network, but you gain some things back, which would be like explainability and kind of human readability. So it'd be interesting to know how the indexers kind of feel about that set of trade-offs.
Yeah, I think this is quite nuanced and complex stuff, right? So Alexis, I think the best way forward is probably if a few of us meet with you, with Brandon, and anyone else you feel needs to be on that session, and we talk through what we need to understand from indexers, and then we can take it to the wider community, maybe as a poll, or if it's something more complex than that, then maybe it's a forum post. But I think it starts with maybe a discussion to outline what the questions are you want to ask. I mean, this is brand new to me personally, so the idea of like trying to understand, where the limitations are in terms of trust, right? You talk about the gateway having, a place to play here. So I would need to understand those things in a bit more detail before we can translate that into, something that we can poll the community around, I think.
It's mainly brainstorming, I think, at this stage. It's also setting the stage for the longer term future, like when the gateway won't be around, maybe one day, or maybe it's not possible, I don't know, but how can we decentralize further? Who runs that neural net? Would people even run a neural net at all? Do we have to do local linear approximations using DSL that looks like Agora? Linear approximations of well, okay, let's go back. So if you imagine a neural net, why we like neural nets these days, what journalists call AI, is that you can map any kind of nonlinear function, and so that's what gives really the strength of those models. However, something like Agora is pretty much a linear model or close to it. So it's so you could imagine that you could train your neural net and then choose to do a local linear approximation of your function being that neural net, right? And in that way, you would have explainability, but also a way to easily compute a cost, as long as you're close to the point at which you extracted your approximation, right?
Got it, right.
I have a question.
Go ahead, Joe.
Yeah, I have a question for you. So let's say that we are all using the same trained model at some point, and then a query gets towards indexers, and let's say there's two indexers, both of them index the same subgraph, which the query is about. So the competition between indexers is going to be who, since the price could be the same, the competition would be who could respond to the query faster than the other, right?
Well, there's more going on in the choice. So even today than the Agora model, there is how much economic security you have. So that's your indexer stake. You have, and things like historical data and such, right? And so this still would be in there, but also the idea would be that you would get an estimation of detailed estimation of infrastructure cost of your query. So for example, if a query generates a lot of egress, but let's say one indexer runs on OVH, egress is free, whereas I run on Google Cloud, egress is extremely expensive, then the query will probably go to the guy running on OVH with the free egress.
The other thing I would add here, which I think the question is kind of getting at, is like, what kind of stops winner take all effects from dominating? So like what stops like a race to the bottom on like price or performance or something like that? I know this was a question that came up from indexers a lot in the early days. And Semiotics actually did some really interesting research on this as well in encoding pro-social utility functions into the indexer selection algorithm. So, we have a lot of selection criteria in the ISA today that, are purely for the benefit of the consumer, things like the ones that Alexi mentioned, like, price, performance, economic security. But you could also, for example, like encode, the expected effects on like the Gini coefficient, right? As a utility function, so Semiotics actually, they did a demo of a really simple negotiation protocol where the agents that were being trained on that protocol were encoding some pro-social utility functions. Might be an interesting demo for a future core devs call, because I think it really highlights, the types of tools at our disposal here to not like overly index on, things that might detract from the decentralization and kind of robustness of the indexer market.
Yeah, I do often wonder, how the wider indexer community feels about that side of the market. We have some documentation around the selection process as it stands today. We know the gateways exist. We don't have any code that represents the gateways. We don't know we know that there's some secret sauce in the selection algorithms. But we don't know the full piece, right? And I think I sometimes wonder if people think that's an issue, indexers specifically, whether they think that's an issue.
I definitely think it's an issue in the long term. So I think the long-term goal of what we want to achieve is kind of what Alexi was referring to, where we have sort of a heterogeneous, and diverse set of ISAs that are being run on consumers' machines, right? So that you don't have these sort of homogeneous decision-making heuristics. And while you have those homogeneous decision-making heuristics, there is some benefits to kind of obfuscation, I suppose, in the same way that Google is constantly obfuscating its search algorithms to avoid gaming the sort of idiosyncrasies of that algorithm. But once you have more diversity of preferences, expressed in the different selection heuristics being used, then I think I think you get a much more flourishing and robust and diverse ecosystem, of indexers on the other side of that. But then I think you can also have a lot more transparency into what those different ISAs are doing and precisely how they work, because really there's no single ISA that sort of dominates consumer behavior. We are going to experiment with some of this in the short term at Edge and Node in the Subgraph Studio. I don't have precise dates on when this stuff will be available, but the goal is to let subgraph owners and creators of API keys basically express preferences to the gateway using something like, you could imagine sliders that say, this is how much I value price, performance, economic security, here's my max budget per query, etc. And I think already that will go a long way towards sort of diversifying the heuristics being used to select indexers.
That's interesting stuff. When did you say you were potentially did you have a timeline at all? Sorry.
No, I can't commit to any timelines on the studio, but it's definitely on the, I would say, short to midterm roadmap. We wanted to make sure that the ISA was working, robustly in and of itself before we started putting too much control into users' hands, and also we wanted to identify what are the right knobs, right? Ideally, we, from just a product and a UX perspective, we're only giving, ideally we'd only give users maybe 3 or 4 knobs. When in reality, if you look at like the hyperparameter space of the ISA, like there's probably 50 knobs we could give them, right? Like, in terms of the weighting of these utility functions, the shape of the utility functions, etc.
Yeah, got it. Okay, we're coming up close to the top of the hour. Does anybody else have any questions for Alexis about the stress test tool or about Semiotic in general?
Hi there. Maybe not necessarily related to the stress tool, but a few questions related to Indexer, if that is of any relevance.
Sure, go ahead.
Right. So first of all, hi everyone. My name is Jose. You might see me once or twice over Twitter or Discord. My question is related more to subgraph development. So I was particularly curious about this comment about some subgraphs being currently landmines, right? And some of them maybe being very memory hungry, right? So coming from a subgraph developer perspective, what can we as developers pay attention to? Or subgraph is most likely, or it has better chances to be picked up by an indexer, or other than signaling, of course, but that that it's just not considered a landmine, so to speak. Very much.
Slim, do you want to take that?
Yeah, sure. So the decentralized network still have some features that are still considered experimental. So if you are to deploy on the studio, you should make sure to avoid those, like IPFS and full text search, I believe. And then when it comes to, we have an episode on developer highlights on how to optimize your subgraph for indexing, and I recommend taking a watch there. But some of the most important ones is to avoid block handlers and call handlers, and to avoid too many eat calls. That is something that an indexer can very easily see from the manifest that you are using block handlers or call handlers, for example. If you can avoid them, then try to do so.
Awesome, thank you. That's useful.
I'll add that I believe there are some open RFPs from the foundation, so requests for grants on static analysis tools to help indexers better assess the costs up front of indexing the subgraph before actually committing the resources. So that's something that I hope we'll see more activity in. And if you have ideas here, please submit a grant.
Maybe on that note, I guess, or will it be fair to say that the latest library by Open Zeppelin that was published, I guess it has quote unquote good practices in place for, if you're teaching, I'm also in terms of, for instance, if I'm onboarding people on the subgraph ecosystem, if I point them in that direction, will it be a fair to say that, the current library has, good practices, so to speak, in there?
I haven't had a chance to review these in depth, but I think it's a safe bet. So Open Zeppelin obviously has a membership on the Graph Council, and Hadrian, who I think has been driving some of the effort over there on this particularly, has been he's one of the earliest subgraph developers, and he's been working, in the graph for, years at this point. So, without having, reviewed the code hand-on, I'd say I have a pretty reasonably high level of confidence in, the patterns they're establishing.
Awesome. That's quite useful. Perfect. Thank you.
I have a related question, actually. What I would like to know as an indexer also is to know if the subgraph is quote-unquote legit, meaning does it come from the DApp developers, basically. So the idea was that could we have like little green verified tick like on Twitter for subgraphs in the Subgraph Explorer or something like that would ensure that this doesn't come from some random.
Actually, that's a great topic. Similar question on this side here.
Yeah, that's a really great point. So I believe the Studio today already supports connecting your ENS name. I don't believe most people have done it, but you can. The Studio and the Explorer will actually show the ENS, like basically that the ENS display name for the subgraph owner. So that can already be sort of a signal if if you're aware of like what the valid ENS name for a project is. But I think one area here where I'm particularly excited is Ceramic. So I'm sure some folks have seen me tweet about this before, that I think it's a really foundational piece to Web3. And the reason is that Ceramic gives us a way of, among many other things, it gives us a way of storing decentralized claims about an identity off chain, but having that used, in applications, so you could imagine that, if you think of the Twitter verified badge as like a claim that Twitter is making about a user, you can imagine a whole bunch of different claim, authorities that are making different types of claims around identities. And eventually, I think as that ecosystem of claims sort of matures, you'll see these exposed in all sorts of different application contexts, right? So even like the Graph Foundation, for example, could choose to be a claims issuer and issue claims about subgraph owners that like, hey, this is indeed this corresponds to like the project for this particular DApp, and that could be a centralized claim authority. It could be a DAO that acts as a claim authority. There's a lot of different patterns that I think will be established here, but I think Ceramic is kind of like the building block that's going to enable a lot of this.
Yeah, that's an interesting one. Kind of like a decentralized version of the types of things that Keybase do, for example, where you have to go out and prove various, you can prove your Reddit name, your Twitter, your GitHub, your DNS, specific website, that type of thing, but done in a decentralized fashion.
Brandon, just to chip in here. So I'm currently working in a project called Hopper, and we are actually heavily using Ceramic for some off-chain verification of our nodes because they have a key. And if you're interested, we can probably jump afterwards on Discord to see if there's any support, because we're in very close touch with Daniel and the Ceramic team. So doing something together will also be cool to get that sorted out. We also suffer a little bit of problem because someone published a Hopper subgraph that did not represent officially ourselves. And there was actually a sizable amount of GRT tokens signaling that subgraph, and we were like, oh, we're not involved in that way or form. So very happy to push that in that direction on our side as well.
Yeah, that'd be amazing. We're really close to the Ceramic team as well, and in particular, Josh and Nader on our team have been getting the most hands-on, I would say, with the protocol. So I may put them in touch with you to kind of share learnings.
Perfect. I'll just ping it on. I'll just send a comment on Discord afterwards, and we can take it from there.
Sounds good. Thanks.
All right, we are at the top of the hour, guys. I just want to say thank you, Alexis, for joining us today. And very quickly, how do people reach out, Alexis, to you or Semiotic if they want to reach out to you?
You can use the Discord. You can use probably email also. That would work. And if you have a post on the forum, you can throw something there too under my post. So yeah. Perfect. Well, thanks everybody for joining, listening, and contributing on office hours.
we'll see you next week for the next one.
Thanks.
Thank you, guys. See ya.